Hello. Let's just... Actually, I'm gonna move where my face is. Make sure everyone can hear me okay? Actually, given that my fan is already going like crazy, I'm just going to move my camera. Just give me a second. Okay, back again. My computer fan was already spinning up a fair bit, so I figured I would move my camera up to the windowsill. So instead of background noise from my computer fan, you can get some background noise from the street outside, although it's pretty quiet at the moment. We'll see how much traffic there is out there later. Not that anyone should really be moving around at all, but, you know, up to them. Okay. So I guess I should address the giant elephant in the room. So this has happened just today, that the course is no longer going to have credits and distinctions and HDs and all that kind of stuff. It's simply got a satisfactory or a fail mark, which means if you're over 50 in the course, you have a satisfactory. If you're under 50 in the course, you have a fail. We're going to try to keep the course as close to how we were going to do it originally. So you're not going to have pass-fail for individual assessments. Everything that we do is still going to have a number attached to it, like the number's not there just to add up to the final mark. The number is there so that you know how well you're going, and you can keep track of how well you've been doing and things like that. So we're going to keep them there. We're also going to give you a final mark. I mean, sure, in your transcript it's only going to be an SY or an FL, like the satisfactory or a fail, but we're going to try to give you an honest mark as we can, because, just to be entirely honest, that's how I wanted to run the subject. Like, I'm just going to be entirely honest here. I'm only 24 hours ahead of you. So about 24 hours ago, I was told that this might be happening and that we would have to try to figure out a way to make this work. And we were just going to have to at least try to make this work in the best interests of our students. There was a survey done earlier that, look, to be entirely honest about that as well, more than 50% of people voted to have pass-fails. So there is definitely a significant number of people who understand that if we're not teaching at our full capability, you can't be expected to be marked on it. Because I was fully expecting the average mark for the course this year significantly lower than last year, because the online teaching wasn't providing as much support to people as it could have. And on top of that, if we can't examine you properly, if we can't examine you in a proper invigilated environment, we can't know if people are actually doing it legitimately or not. And if we can't know if people are doing it legitimately or not, then people are going to unfairly get higher marks than they should have. So I guess what the university has done here is, in the interests of fairness, they have they've hit all the subjects with what I like to call a fairness sledgehammer. So we're so fair now that you don't necessarily have a solid record of whatever success you have had in this course. We're going to try to still provide you with that. So if you are doing this entirely legitimately and you're putting all your effort into this, you really want to learn what we have to teach, we're still going to try to give you a mark. We're still going to mark everything. We're not going to just slack off and not put our effort in because the course is now a pass-fail. We're going to be putting every effort we can, myself and the tutors, to still have all the coursework marked to the same standard. And like, even though we know that the difference between like an 85 and a 75 for some people is now not really going to be that big a difference, we're still going to treat it like it's fully important. We're going to treat it like that's your actual mark, and we're going to try to give you complete and proper feedback for the work that you've done in this course. Now, I fully understand that that's not enough for some people. I fully understand that this change, which is highly unprecedented, usually you can't make changes like this to a course at this stage, and I know people have issues with this. The faculty has set up a web form where you can make requests there, so if this is an issue and you want to, like, I don't know, if you do want to drop the course and take the course later in the year or something like that, you can talk to them about it. I don't really know the full situation or how that works, but I know that there was an email sent out to students. I don't receive those emails, so I don't even know exactly exactly how they're presenting that to you. But there are options. Otherwise, as far as I've been told, the school and the faculty does understand that while the satisfactory versus fail marking scheme doesn't allow you to have courses like this have an effect on your weighted average mark, they will take that into account in the future. To be honest, I don't know how they're going to do that, but I assume they will do it in some way or another. Sorry, I should probably check what's happening in chat in case people have questions about this kind of thing, but I figured, I don't know about you, but this has occupied all of my time for the last 24 hours, so everything that I wanted to prepare for this live stream just hasn't happened. But I figured I had to at least talk to you about it because this is something that's important to you, and this is something that's going to cause some difficulties for some people. I mean, for some people, they're like, woo, no worries. 51, thank you very much, and fair enough. But for other people, they were looking to put a whole lot of work into this course. And for those of you who are in that situation, I mean, I've gotten a lot of Hall of Fame entries already from people's, which means people have completed the entire assignment and then are working on extras. For those of you who really did want to put your all into this, can I suggest that you still do that? Like, I know now I have no magical numbers to offer you. I mean, I can still give you those magical numbers, but they don't really go into the university system in a complete way. So I can't just kind of wave my magic wand and hand out marks to convince you to do extra work. But what I can say is that there's nothing that I was going to teach you that I was doing just to get you to do something. Like, there's no point, there's no space in this course for me to throw things in that are just like, oh, I just need to fill up the student's time. There's nothing of that in this course at all. Every single thing that we're teaching in this course is useful, and you will need it in the future. So whether or not you're getting marks for it, everything that we're teaching you, you need to know still. So I hope people can kind of take that into account, because whether or not you need to get a lot of marks in this course or not, depending on what you want to do in the future, and I know that, like, because this is first year, first term, everyone in this course is enrolled in a computing or related field, so computing, data science, software engineering, computer engineering, and all of those. Possibly some electrical engineers in here, depending on what your focus is. Electrical, mechatronic? I can't remember. Maybe this term or next term. It doesn't matter what marks you were going to get. You still needed to know it all, and you were going to have to learn all this stuff eventually. So I hope you're still willing to put some effort in. Um, the request from me to you to put effort in can no longer be, I have assigned marks to this because I think it's important. It now comes down to a point of like, can you do it because I think you're going to need it? And it's turned from a sort of an official university thing where I'm like, these marks are assigned to this, so you have to do it, and then now it turns into a bit of a personal thing, that I, as your educator, have put together this course because I think it has value to you as a student and value to you as a computer scientist, and I hope you see that value. And if you don't see that value, then that's okay. These are not times that any of us expected we'd be in. Even about 3 or 4 weeks ago, like I'd say 4 weeks ago, we were still like, this is really unfortunate that some of our internationally based students couldn't take part in our course, but our course is fine. And now we're on lockdown, and we're going on this kind of health trajectory at the moment, which is looking really, really bad for New South Wales in particular. But I mean, the rest of Australia is just a little bit behind us, and we're going to be in some dire circumstances soon. So none of us predicted that this was going to be like this at the start of term. None of us thought that we would have to reshuffle the whole course online, and then after that look at an online exam, and then have to switch to a pass-fail, and sort of inflict all this change on you when at the start of term you probably hadn't intended on doing a course like this. So I just hope that everyone is still, at least to a certain extent, interested in continuing to learn. And I know that a lot of people, your schedules and your entire lives have been flipped upside down by the COVID-19 pandemic. So there's going to be situations where a lot of you need to stay home and look after people. You need to go into quarantine yourselves. I hope against hope that none of you are actually put into life-threatening situations by this pandemic, but knowing the number of people we have in this course, that's statistically very unlikely. So I just hope that when the life-threatening situations come around, that we as a course and a university can at least try to support you as best as we can. Yeah. I don't know if there's anything else I really wanted to say, but I'm sure that there's going to be some questions in chat right now. So let me at least look through the chat and see if people have things that they wanted me to clarify. You're trying to push discrete maths into making a pass-fail. That's pretty funny, because discrete maths only works in ones and zeros. Anyway, that's logic jokes. So it's you get a true-false as your marks at the end of discrete maths. Okay. What are people saying? Someone's asking about being disadvantaged for your WAM because people in the later years get a harder course off, whereas you get an easier course off. I wouldn't necessarily say that. The later courses may be more difficult just by definition because the content they're doing is just later. I just realized that my Facebook is pinging. Hang on a second. I don't want to show you my screen when I go across that. I'm just going to close those other windows. Be right back. Alright, I'm back. Just muted the other things so they're not going to interrupt while we're talking. I forgot today. I mean, like, it's been a bit messy the last day or so, so I forgot to close all my other windows as I usually do before I start streaming. Yeah, I mean, like, It's hard to say whether you're going to be more or less disadvantaged than someone who's later in their degree. I feel like people who are nearing their end of their degree now are having the final part of their studies cut off by this crisis. They're not going to get to see the university go back to normal, and they're not going to be able to finish their university degree the way that they'd intended. I don't know. I don't really want to say that any person's more disadvantaged than anyone else, but I feel like that would put a really big hole in the way that you kind of see the way that you finish your time here. All the courses are getting marked differently, so I can't really say how things are going to work out. There's a lot of people in the later years who are worried because for a lot of people, they get the hang of university as it goes along and they get better. Their marks get better, and so there's a lot of people trying to scrape themselves up into a higher bracket for their WAM, and they really need these later year courses to push that. People are trying to apply for honours and stuff like that, so I think that the effect on your WAM as a first year student, it will have an effect, right? Especially if you're thinking of transferring to another degree or something like that. You need to have a certain amount of WAM that says that you're capable of doing that. Now the faculty in the school have said they're going to take that into account, but that's up to them. I don't know how they're doing that. I don't know whether they will come to me and ask me to assess you in a certain way or something like that, but what I'm hoping is that this whole thing is just a one-off that causes a whole lot of disruption for a bunch of students, but doesn't single people out for unfair treatment. It doesn't allow other people to unfairly take advantage of the situation either. And I think that may be what the university is thinking with the pass-fail thing, is if you sort of neutralize a term, then no one gets undue advantage or disadvantage out of it. I don't know, I'm only one lecturer. This wasn't my decision. This is something that the uni flicked a switch on for everyone. I looked into ideas for how we could try to do an exam online that was still as provably fair as an invigilated lab exam, but I couldn't do it. And that's the notice that I sent out earlier today, apologizing that I couldn't find a way to do that. So there was no way for me to keep business as usual. There was no way for me to say the course is going to continue as it is. So we had to switch over to the pass-fail. Alright, let's see what other questions people are asking. People are saying all faculties are going pass-fail now, and that's a reasonable likelihood. Engineering, from what I know, has all gone now, apart from subjects, I think only subjects like theses that are assessed individually, or project-based subjects that don't have a final exam, so they were going to be assessed in person anyway. Anything where the assessment wasn't compromised, I think. As far as I know. I mean, that's as far as I can see. A lot of this is speculation on my part as well. I'm not magically connected to the decision makers in the university, and I don't know what they're thinking. So I'm interpreting what they're passing down to us. So someone was saying the maths higher courses were still being marked normally, but I don't know. It's not for me. I don't know what maths is doing. I've got my orders, which I'm going to follow, which is that we are going pass-fail, unless I could magically run an exam where you run it at home on your own and no one can cheat. There's no way I can do that. I don't have that level of magic. I'm pretty magic, but not that level of magic. Okay. Yeah. People talk about different courses. The engineering faculty will be releasing some information but it might not be until early next week when they nut out, because when they release information, it's not going to be just the little email that I give you. It's going to be a whole like web page saying, okay, this is exactly what's happening, and here are all your options and all this kind of stuff. Well, I hope. I don't know what they're doing, but I know that they're putting more work into it than, for example, the school and myself was just like, we need to get a message out to the students as soon as we can, but we haven't rewritten the exam yet. So that's going to be a whole lot of work for us over the next few weeks to take the exam that we were prepared to do as a closed book exam, and then see how we can do that as an open book take-home exam, which is a very different beast. That's why I can't give you that much information on it other than the rough timing of it. That's going to be a 24-hour thing that you get to take home. You can do what you want with it without collusion with other students, but you can look up stuff on the internet and things, and you can definitely use things like all the lecture slides and stuff like that, and all of the videos and things. So with 24 hours, I mean, I think there's a lot that you can do with that in an exam to prove that you understood everything in the course. We'll see how we go with it. It's definitely not going to have the time pressure that a 3-hour exam usually would have. We're not going to make a 24-hour exam actually need 24 hours, because that would be a little bit immoral, I feel. Come under the Geneva Convention as torture or something like that. Okay. People asking a little bit about like what kind of topic material and stuff. I think Tom's been answering a lot of these questions in chat, which is handy. William's asking about submissions and whether we're checking how many times you're submitting and stuff like that. And not necessarily so, but I suggest you should anyway, because it's a really good way of doing backups. Not only will it back up every time you use give, you can actually jump back to different points that your different states that your program was in, if you need to go back and check on things. But if you haven't submitted yet, it's not really that big a deal, as Tom's saying. Michael says, "Oh hi, Mark." Oh hi, Michael. I didn't do it. I did not. Anyway, yeah. Richard was asking if there was a thought of a replacement assignment. We did entertain the thought of doing a third assignment instead of an exam. But the thing about the first two assignments is the first two assignments kind of test the whole course. Like, first assignment tests the first half of the course, second assignment tests the second half of the course. The exam was meant to be an amalgamation of all of those. If we were to do a third assignment, we'd have to write a third assignment. I don't really have the time. Assignments in general. So the funny thing is, like, you do the assignment and you're like, I'm going to spend 3 weeks on this. I'm going to pull all these all-nighters and stuff to get this done. There was at least 2 all-nighters pulled on Minesweeper before it was released. I threw one of your tutors in the deep end when I said this thing has to be ready for internal testing by a certain date. And I'm not going to say who it is, so I'm not going to throw them in the deep end, but they had to pull an all-nighter to get my first build ready before we could do a certain amount of internal testing and stuff on it. And then later on, I'm pretty sure there was another all-nighter pulled to make sure that all the changes to the spec were up to standard for release. And even then we have trouble with it, right? So like, I don't have the time to do that. We can't make a third assignment. I mean, we could, but something else is going to lose out. The lectures will just be recycled from last year instead of me doing updates on them or anything like that. And I don't 100% consider that worth it. So what we're going to be doing is taking the exam questions we're intending on asking and then modifying them somewhat to take into account the fact that you've got a lot of resources. So we won't test you on things that you sort of have to remember. We'll test you on how well you interpret things that you should know instead. It's difficult. It's a lot of rewrite. I mean, I don't even know if that's less effort than writing a new assignment, but I think it is. We'll see how we go. Someone's asking about a WAM to maintain a scholarship, and you don't have a WAM yet. I am very sure that the scholarships office and the faculties and schools that are administering these scholarships know that this is the situation, and they know that their students coming out of the first term may not have any WAM at all. They know that, and so I'm going to assume that your scholarships will be discussed with them, and they will have some arrangement for that. In general, scholarship officers never plan for, like, they don't have a quota of people they have to fail out of their scholarships, right? They never plan for that. So they will be hopefully expecting everyone to just continue with their scholarships unless they fail all their courses or something like that. So I think that that's not going to be a problem. But obviously, I'm not the scholarships office. I shouldn't even be answering that question, to be honest. Talk to them about it. They will have a real answer for you, rather than me just trying to reassure you. Someone else got an email. There is no percentage mark. The satisfactory fail grade would have no impact on your WAM. Yeah, as far as I know, that's true. As far as I know, the number that we give you, because we're going to try to give you a number in COMP1511, the number that we give you is not going to go into your WAM calculations. It can go into your personal calculations in terms of how well you did in the course. If you cheat on the exam, you can go into your personal calculations as the marks that you stole. Like, yeah. Which is why it won't go into the official record. Because if I give you a take-home exam, I don't want to say it. I'm not going to say it, right? Because anything I can say after this is just teaching you how to cheat in the exam. So I'm not going to say all the ways that you could cheat in the exam. But because I don't have someone standing over your shoulder watching you do this, I can't tell that everyone is legitimate. And that's why I can't give a number mark anymore for 1511. It's unfortunate, and there's very little I can do about that. Because if we were doing it in person, we have invigilators in the exam walking around. They're looking over your shoulder. They're looking at what you're typing in. They check your student card and your face. They make sure it's you. All this kind of stuff. And then we can verify that we have assessed you, 100% assessed you and your ability. And we can't do that with a take-home exam. So that's the way it has to be. I don't know, but I think that was one of the major stumbling blocks. Because I had a massive cram with Tom, who's in chat at the moment. We had a massive cram over the last 24 hours, seeing if we could find a way to run an exam that was still a legitimate exam. But we couldn't find a way where we could prove to the faculty that it was without a doubt as strict and objectively correct as an invigilated exam, where we literally have someone looking over your shoulder, which we would have. They walk around the rooms, look over your shoulder while you're coding, to make sure that you're 100% legit in what you're doing. So yeah. Sorry. I apologize, everyone. What you're getting today is probably the most deflated Mark Chi that you'll ever get. But I think at some point we should stop talking about this and start doing some code. So I'm going to have another quick look through the questions that we got in our live chat, and then we'll actually go into some actual topic material, rather than just dealing with the pass-fail thing. Which, I mean, we have to deal with it. We have to deal with the pass-fail thing, because usually we would not make a change this drastic halfway through a course. This is totally not what I do or what I want to do, but it's something that we have to do. So we don't have a choice. We have to make the best of it, right? So we have to try to make this course work, and hopefully for all of you, we can get you to a point where you've still learnt the things you need to learn to have a productive continuation into a computer science degree. All right, let me have a look at the questions and see what we got here. People asking about some other subjects, not much information there. was the scholarship question there. Percentage. Oh, do structures in C serve the same purpose as factory functions in JavaScript? I hope there's someone here who uses JavaScript regularly, because I have used it only at a very surface level, so I'm not exactly sure what the term factories in JavaScript is. I would have to look that one up for an answer, but Tom's answering that anyway, letting Jeremy know that structures are a subset of what objects in JS do. Yeah, so maybe they're close. Maybe you can think about them to a certain extent in the same way. I'll show you some struct stuff today, because I do have some struct stuff. I actually just scavenged a lecture from last year. I was going to rewrite it for this, but I got a little bit busy over the last day, so I didn't do anything with it. Yeah, so Tom's got some information in chat to answer that question. Are we reviewing content today? Usman is asking. Yes, we can review content today. This can be very question-driven if you want. I also have some code that we can write that I would spend maybe 45 minutes or an hour on, depending on how much that is. The code that I could write is a thing that uses structs and pointers, so it might give you some insight into the newer stuff that we're doing, but if we want to go back over the older stuff as well, I'm happy to take people through some of these things. Okay, scholarships questions are coming through as well. Again, unfortunately I can't answer those scholarship questions, but the scholarships office should be I think at the moment ready and waiting, or on hold, because so many people are actually asking those questions already. Rachel's asking, the take-home exam still weighted to 50% of the course. Haven't entirely locked that one down yet. With the take-home exam being a little bit like an assignment in the way that assignments are just massive take-home exercises, we may shift the weighting a little bit more. We won't make any changes to assignment 1 though, because we can't. Like, I'm not going to make changes to something that's due in 3 days. Yeah, 3 days. Like, that's not fair. But I might potentially put some of the weighting that was in the exam into the second assignment, because just by virtue of the assignment being out for 3 weeks, you're going to spend more time on the second assignment than you are on the exam. I have to put a significant amount of weighting on the take-home exam because it's going to cover all the topics. So it's going to cover like 10 weeks of topics. So it needs to have a significant weighting because it's checking the breadth of what you know in the course. The second assignment's only checking what you know in the second half of the course. So it'll be slightly different. I don't think I'm going to shift it very far. So even if I do change the weighting, it's not going to go very far, and that will happen, you know, I guess over the weekend. I guess I'm working through the weekend again. It's the way this is now that we're all working from home and online. There's no weekends anymore. Okay, but yes, as Tom said, still sorting that out. Is the exam through Examity or similar software thing? No. We've got our own systems. Like, you've got Autotest and Give and stuff like that. We've already set up our systems to work quite well with the way that we write C code and the way that we're expecting you to do it. So we're not going to be doing a different kind of environment. So it's going to be like you're now doing with your lab exercises and stuff, like you've been doing with the weekly tests and your assignments. We're going to keep it within our system. Okay, so I've reached the end of the questions there. So I wonder if I should jump into this coding that I've been planning on doing. This is going to be rough because I haven't looked at it for like 6 months, but I've got 2 options. So the first one is I jump into a coding example. A coding example I think is going to take about 45 minutes. This is a coding example that uses structs and pointers. It uses strings as well. So all of the most recent topics that I've delivered for you, this is going to tie them all together. It's obviously going to use other things, like it's still going to use while loops and stuff like that. So that's one option. The other option is if people want to ask me questions about particular topics to review, I can go back and review those topics. Chances are we've got time for both of these things. Let me just ask one thing. We also don't intend to be doing any intrusive monitoring like Examity does, if that's what you're worried about. What does Examity do? Is that one of those things where you have to have a webcam and it's on and it looks into your house? Is that one of those? I'll just wait for an answer because I know there's a bit of delay between when I say stuff, when it streams to you, and when you get a chance to answer. But you can answer whether you want the new stuff first or to go through old stuff. And I know I can see there Sam has already said that new stuff is something that they want to do. Wow, you turn on your webcam and have to give it a tour of your room. No way. That if people are, if people had access to somewhere else to go, so they could go to their local library and do the exam there, they could go to a public place and do the exam there, but if people are locked inside their houses, there's no way I'm gonna allow an involuntary invasion of privacy like that. No way. Yeah, so that's definitely not going to happen. Yeah, so you also have to do this, and then we do a full retinal scan on you to verify who you are. We don't even have retinal scans, but no, we're not going to do that. I mean, if we were going to do something silly like that, then yes, I guess we could have done full marks and stuff like that, but at what cost? Frankly, I consider that level of invasion of privacy just pretty unsettling and a little bit creepy. And sure, I know this is probably happening in some other courses and stuff like that, but for me personally, there's no way I'd ever do that. I don't think I could stomach that kind of thing. So no, now that I know what Examity is, you can consider it crossed off the list of things that I will ever touch in my educational career. Because that is a weird thing to do. Anyway. So Tom's answering some stuff, control your computer, blah, blah, blah. Funny part is we teach people how to do problem solving, so you'd probably still be able to cheat. Yeah, if we had a webcam aimed at your face, or something like that, we'd have to see everything on your computer as well. Oh, it's just messy. I mean, and also, I'm not going to have my invigilators sit there for 24 hours watching people on their webcams. That would be so silly. Yeah. Okay, so I've gotten 2 answers at least, saying structs new content would be appreciated, some coding on character struct pointer to revise how to use them. And Paris is saying, yeah, you could glue paper on the side of the laptop and the webcam can't see it and stuff. Yeah, so it's just kind of stupid. So we're not going to do stupid. I apologize. This is going out publicly, so there's other teachers out there who have just had me calling their exams stupid. I apologize to those people. I should rephrase it and say it's not for me. It doesn't align with my personal values and the way I would like to teach. You can do whatever you want. There you go. Disclaimer away. I think I've made it clear how I think about it anyway. Okay. I think we've talked long enough. That's 40 minutes just talking about what's happening with pass-fail and stuff like that, but I think we kind of needed to talk about that. And also, this stream was not really an official lecture or anything like that. I don't have any content I have to get through, so I think this was a good time to have a chat about the fact that we have to go pass-fail. I understand there's a lot of reasons why I don't want to do it. There's reasons why I accept that we are doing it. There's reasons why making big changes halfway through a course are super disruptive to people's learning and people's rhythm and just sort of like how you're going. It really kind of threw a spanner in the works for me as well, in the way I was thinking about the subject and the way I was like wanting to deliver things. But it's happening. There's nothing I can do. We're going for it. So we're just going to make the best of it. And in the spirit of making the best of it, we should write some code, and we should teach you some things about writing code. So, there's other questions here asking about use of functions to prevent too much nesting. So someone's obviously got 1511 style on their back telling them their nesting is too deep. Let's see. Okay, I think this is a good time for me to launch into the example that I had planned. And we'll see how much this helps. Because I think it's a pretty complex example that may have some deep nesting in it if we don't do anything. Francis asking what nesting is. Nesting is if I put a while loop inside a while loop, and then I put an if statement inside that while loop, and inside that if statement I run another while loop. That's called nesting. So nesting is like the curly brackets and something goes inside it. And then if you go deeper and deeper with that, the deeper you are in it, the less likely you are to remember where you actually are. So you're like, okay, we're in this loop, then we're in this loop, then if this if statement happens, then this means this thing exists, and then we loop inside this. And so when we're running through this loop, which of the other loops are we in and stuff, you know, it just makes it really hard for humans to understand what's happening. And so what we usually try to do in those situations is when we get too deep, we try to move some stuff into functions. Even if the function's only ever going to get called once, this can still be a good use of a function. So we nest to a certain depth, and then we get a function which is this really clear human word that says, do this thing. And you're like, oh, so we nest to, so we do a while loop, and then we do another while loop, and we do this thing. And inside that thing is the stuff like the if statement and the other while loop. So what we get there is that we can say that the double nesting meant that we were checking every square in the minefield. I shouldn't really talk about the assignment specifically, but I know it's an example that we're all involved with. So if I want to check every square in the minefield, then I would do a double while loop that goes through the coordinates and checks every square. And then for every square in the minefield, I can call a function. And that function's called, I don't know, check for mines or something. I'm not going to write your functions for you, but if it's check for mines, then it can have its own loop or its own weirdness or whatever it does inside. But when you're reading through how things work, you don't have to think about all the while loops and stuff that were inside it. You only have to go check for mines. Oh, that's a concept I can understand. I'm just going to assume that function does that. And then your nesting is really shallow because the only thing you had was the double while loop, you know? So I don't know if that helps to understand what it means. Francis. So basically my whole assignment. Yeah, so good example for this is if you go back to, it was one of the live streamed lectures where I did, was it the tourist? It was the tourist, or it was one of the other ones where it was like, do this, then do this, then do this. And the main function ended up 4 lines long. It was beautiful. It was like really short. And then each of those functions was its whole big thing with its multiple while loops and all this kind of stuff. And one of the functions, actually no, I don't think it was a tourist. I think it was later. I can't remember what the example was after that. My head has been in a completely different place, like on course admin. So it had just a couple of functions, and one of the functions even called one of the other functions to make it separate. And it was the swap, it was the jumbler, that was the one. So there was one that just swaps 2 numbers, and one that went through and swaps different sets of numbers. And so all of those were functions that were just run one at a time, and then you could just read the words and see what this thing did, and then the code itself was just sort of packaged away in these functions. Valnorth 1001 is asking, can functions have numbers in their name, like reveal 3 times 3, or is that bad style? No, that's not bad style. You can do that. Just don't put a number at the start, because that's super confusing. I think that's illegal C. I think C won't even read a number at the start as a function name. A lot of the rules that we had for variable names, which were in one of the early tutorials, a lot of them are the same kind of rules as we have for functions. So our naming in general, for most things, is going to start with a lowercase. That's only functions and variables, by the way. There are other constructs in C that we would use that would have capitals. We're actually going to talk about them at the very end of the course. Yeah, so you can have numbers at the end and other stuff like that, or numbers in it. I mean, a lot of them, like your one there, reveal 3 by 3. If you spelt that all out in words, you'd kind of end up with a function name that's very long. Long enough to be annoying to read because it's like stretching out over half the line. So I think what you've got there is probably pretty good style. And just from what you're saying, reveal 3 by 3, I actually have a really good idea about what that function is. So I would call that a good function name. Okay, I'm gonna jump across to my slides here. So this is from last year. So last year I had just been rewatching Avatar: The Last Airbender, and so I decided to put that in as the examples of things. So you're gonna get Avatar again here, even though, oh, you know what? I'm just gonna drag this window out. So I've only got this window. All my other tabs are there. You don't need to know about those other tabs. There's a whole bunch of admin in those tabs. So this is a fight between Elementbenders that's happening in a forest somewhere. The forest is not relevant. It's not part of the code. But it's some code that just sort of simulates this fight and these people attacking each other. My plan before we had to just sort of do all this admin to re-administer the course for things is, I'm just going to tell you about it because, like, I'm not going to get to do it, but I want to tell you about it anyway. I was going to bring in some education to everyone about classic rap and hip-hop. So it was going to be a rap battle between the Wu-Tang Clan and probably NWA or someone else. And I also just didn't necessarily only want to bring in the Wu-Tang, right? Because, like, I wanted people like Q-Tip and maybe the Beastie Boys to end up in there as well. So this is golden era. It's not even the golden era. It's the era after the golden era of hip-hop, which I wanted to educate you all on. I won't necessarily get a chance to educate you all on it, but personally, that's what I've been doing over the last couple of months. Is I've had a big sort of resurgence into listening to things like Wu-Tang, and even further back in time of Grandmaster Flash and the Furious Five and all of them and stuff. And it's super interesting, maybe to me, maybe not to you. That's why I was going to force it on you in an example. But no, we're not doing that. Instead, we're going to just continue with this example that I had from last year. So we're writing some code about Elementbenders having a fight in a forest. So this is going to be 4 benders. I hope people do know Avatar: The Last Airbender, and if you don't know it, and you're stuck at home for the next few weeks, it's on Netflix, and I suggest it is a really great series. It is super wholesome, and a lot of fun, and it's got a whole bunch of like ancient Chinese mysticism magic in it, which is also a lot of fun. So it's like a hero story while also just being this really cute wholesome TV series. So yeah, there's a couple of people who are saying that this is important to them, so I'm happy that it is. Okay, so when I introduced structs, I went K-pop last week, and now we're just gonna flick over to animation instead. This is actually American animation, if I remember correctly, so it's not actually anime. I think, yeah. No, it totally is American. Because the same person that worked on the Clone Wars and other stuff like that. Clone Wars is really good as well. Anyway. Just random stuff from Mark again. Okay, so here's the idea of what's happening. 4 benders, 1 very powerful enemy, which means we're going to have a collection of some kind of benders, and 1 very powerful enemy, so there's going to be 1 and many. You can see me already starting to think about different variable types here. One's going to be an array, and the other one's going to be a single variable. We're going to create a struct that represents a bender. So the enemy is also a bender, the team is benders, so we're going to create our own variable type. We're going to create a struct that's a bender, and we're going to use it for each of those. 4 of them are going to be in a team, 1 of them is going to fight them all. We're going to have some functions that are going to make these benders fight against each other. So I'm hitting all the triggers here. Hey, Clone Wars is classic. I'm going back and rewatching that now. I should... No, okay. I was going to say I should put their names in this, but no. I would usually prepare stuff before I use it. So we're going to stick with Avatar for the moment, and I've got some support for that in chat anyway. I don't know if I'm aiming over this way when I say chat. I don't know if your live chat's in that direction as well, but that's where my other monitor is. So whenever I look over there, it's because I'm reading chat. Okay, so we're going to have some functions that are going to put these benders against each other. So we're going to have them doing damage to each other and stuff. So like in a game, we would have hit points and we'd have the amount of damage people could do and stuff like that. And we're going to use a struct to represent that, because when you think about it, a struct is able to represent who someone is with, say, a string. Now that we're looking at characters, we can use strings. What element they are as well, so we could have an element, we can put numbers in there, like how much health they have, how much damage they do, and so we can build up this information in our struct, and then we'll be able to use this information to be able to run this sort of simulation of a fight. We are also going to be looping these attacks, so we're going to go back, we're going to be using everything that we've seen so far. So looping if statements, arrays, characters and strings, structs. I'm pretty sure there's going to end up being some pointers in here as well. So the whole thing is going to sort of tie in everything that we've learned so far. Paris, I have not watched season 7 of the Clone Wars yet, so if you say anything about it in here, we're going to find out what the difference is between pass-fail in this course. I kid. No, I actually don't kid. Don't have any spoilers. But yeah. Alright, so the first thing that we're going to do is create some structs. So I'm going to create a struct called bender. I'm going to say this was the slides from when we created earlier, because this was the kind of thing that I had in the previous slides, but that's okay, we can build this thing from scratch. Okay, I'm going to go back into VLab here, go to my COMP1511 directory. I don't actually know which lecture number we're in now, because this is not actually a lecture, so I'm just going to make a directory called stream code that has my streaming code in it. I'll put this up on the website when we're done with it as well. I think it could be useful code to have. Okay, go into my stream code directory, and I'm going to call it bender fight. So I'm just going to use gedit to open that. Let me just make sure my face isn't covering things up. Alright, good. Let's set up our file at least so that we're ready to go. Demo of structs, strings, and other C constructs. Bender fight pits 4 elemental benders against 1 strong enemy and simulates a fight between them. I could put more information there, but for the moment I'm just going to leave it as it is. There'll be information in it for exactly how it does these things. Sam's saying when we put things in quotes, double quotes like hello world, and printed that out, that was a string. Yeah, that was a string. It was a series of characters together. That is the string in terms of what we would think of as the value of a string, in the same way that a number is the value of an integer, can be stored in an integer. Hello World was never stored anywhere, so it didn't necessarily have a memory location that we could change things from, so we wouldn't consider it the variable a string, but we can consider it a value that would be stored in a string, that double quotes stuff. So it's slightly different because it didn't have a piece of memory that we could edit. But you can still consider it a string. Francis, when you're saying Mark has a website, I'm talking about the course website. I'm going to assume that you're a COMP1511 student. I just assume that most people are. Unless I've got random people just learning programming. That would actually be kind of cool if random people have just found my YouTube stream and are just like, oh, we're just going to learn how to program from this guy. He just happens to be doing it, because I'm going out public, I don't mind. Otherwise I would have to like figure out login details from everyone to limit the stream and stuff, and I can't be bothered doing that. So when I say the website, Francis, I mean on the COMP1511 website, where you can go into the lectures section. In there I'll put the code from this program that we're making today. I'll put my email address in there. My course email address at least. 26th the 3rd, 2020. Alright. Things that I think I'm going to need. I think I'm going to need standard input output. I don't know if I'm going to need anything else, but I think I'm going to need standard input output. Okay, so I've got my main function. Here I have an entire program. It doesn't do anything, but at least it's an entire program that can start and finish. Now, here above my main, I'm going to need to declare a structure. So if I want to use a structure, I need to make sure it exists first. So I say struct something. Structs are declared in this way. I mean, I haven't put the name of the struct there, so I'm going to struct bender. So they're weird in that they have a semicolon where something like the main function does not have a semicolon, but they do have the curly brackets in the same way that other things do. So the curly brackets is still containing a bunch of information, but the struct itself has a semicolon because it ends in a different way than a function. So it's nearly like a single piece of information. Going back to the slides there, we've got we were going to store a name in there, and I've got this all caps here saying maximum length. So it looks like I was limiting the size of the arrays that I was storing names and elements in. So if I'm going to store names and elements in a certain certain size, I need that size hash defined before I can do this. So I'm going to do that. So this is the maximum number of characters that I'm going to use for either of these things. Thinking of the names that I'm using and a little bit of a buffer just in case, I'm going to keep this reasonably safely above a certain amount. I mean, knowing all the names in Avatar, like, I really don't need more than about like maybe 10 characters for each of these. Okay, so what I'm doing here, this is not one of the benders. The structure represents a variable type that I can use in multiple different places. So this will be like me saying int, and then explaining in here what an integer is. So I'm saying struct bender. I'm saying struct is a keyword in C. You can tell because it's highlighted with the bold red. It's saying we're about to tell you that we're putting together a structure made up of other variable types that will come under this name, struct bender, and then we will say what is inside it here. And so what we're going to do now is say, okay, these are all the parts that make up a bender. So I can say I want a name, which is going to be a character array of max length. Did I just call it name? I'm pretty sure I just called it name. yeah. So this is the variable type, the variable name, and then the square brackets makes it an array. So it's just a character array here that has space for 100 characters in it. And so we're expecting the names to not be longer than 100 characters. I doubt there's anyone in Avatar, even if you added on all of their titles and stuff. Like, I don't even know how many titles there were. Marshal of the Grand Fire Navy or something like that. That's still probably not going to be 100 characters. I don't even know who that was. Anyway, so each of the benders, so if you haven't seen Avatar The Last Airbender, it's about these people who can control elements, and anyone who can control an element is said to be bending that element, you know, like bending an element to your will, that kind of thing. So that's why they're called benders. So a bender is a person who can use an element. So each one will have an element. And I know Aang can use more than one element, but maybe I'm pitching this to like season 1, where he could only use air at that time. Okay. Why is Tom saying which you should all see? Oh, wait, he's talking about you should all watch Avatar. Right. Okay. And so, because the only thing we're worried about here is like how much power people have, so how much attack they're going to have and how much health they're going to have, those are two things we're going to store as integers. What order was I doing them in? Power and health. Actually, the order doesn't even matter. So they're going to have an integer for power and an integer for health. Note what I'm doing here is that these don't have values, right? This is like me saying, this is an integer stores 32 bits of information that stores a number. This is like me saying that, but at just a slightly higher level, saying a bunch of characters, another bunch of characters, an integer and another integer. With that information, we can then make benders, and each bender themselves is going to have different values inside here. So this is us making a new variable type. It's not making a variable at all. There are no variables yet of this because I haven't made any in here. But it's saying that if I want to make something called a bender, it's going to have all this stuff in it that I can then fill out with information. So that is how we declare a struct. And this means this is now available for me to use anywhere else in this program that I want. Because you notice that it is not contained inside any curly brackets. It's got its own curly brackets with which it contains something else. But the concept of struct bender was not inside any curly brackets, which means anywhere in the file you can use it for stuff. Okay. So the next thing that we're looking at, I'm keeping the slides in the editor mode just because my head will cut off. Like, let's actually check. Yeah, no, my head's still cutting off stuff. I'll just leave the slides a bit smaller. I mean, the one thing about not having to worry about projectors in the theater or anything like that is I don't have to keep everything really massive so that people can see it from up the back. So if this is a little bit smaller, you can still see my face there, and you can see this. So this is me setting up the team by, first of all, making an array of benders at a certain size. So we have a team size here, so we need to figure out exactly how big this team is, and we can make an array of these in this way. So let's go back to our code, to our main here, and set up this array. So in order to make an array, in the same way I made this character array, the first thing is the type. And it's interesting because the type is now 2 words. Struct bender is a type now. It's a type of variable, and so I can say struct bender in the same way that I would say int. It occupies the same niche or the same purpose in a C program. You can see me trying to dodge the word function. Like in the back of my head, it's like, this is the function this has, but no, function's a keyword. So this is the purpose of the word struct bender now. Struct bender is an identifier for a variable. So if I want to make a single bender, I could make a bender called Aang. But if I want to make an array of benders, I'm going to call them the companions. And there's going to be a certain number of them. And I said in the slides there that I'd hash define a team size. So I think that's not a bad idea. I can hash define a team size. Oops. At which point are we? No, I'm going to keep it small. I was like, if we go into like season 3, there's like a lot of them, but not even that many. But like, I'm going to go, let's go like season 2. Season 2, I consider there to be 4 benders available. So there's a list of companions, and there's 4 of them. No, Tom, we are not going to do Boomerang. Apparently I'm getting a lot of dropped frames. Is that a problem for anyone? I mean, hopefully, like, you know, my content is not super interactive enough for you to need every single frame. So I'm dropping a few frames. Hopefully that's still okay. We're dropping more frames than we were previously. I think a lot more people are just staying home now, and so our internet is a little bit more being used a little bit more. Okay, so if I have an array of benders, then what I can do is go through, I'm just going to put them white space at the bottom here so I can work near the middle of my screen. I'm going to go through and put some information in here. So I can say companions as the array. The first element of the array is companions 0. Yeah, Francis, we are probably going to use them. Let me check. Did we use pointers in this? I'm pretty sure we did. Yeah, there's definitely pointers in here. There's pointers to an attacker and a target, and then how we're going to make changes to them and stuff. Yeah, we're giving addresses to functions. We're actually passing pointers. There's going to be heaps of pointers. Yep, lots of pointers. Okay, so the first thing we're going to do is we're going to fill out some information for these. I'll do the first one slowly, and then the rest of them will be reasonably easy to go along. So the first of the companions is going to be Ang. So to access the element, the field, they call them, inside the struct, I access the struct itself. So companion 0 gets me a single instance of a struct bender. And I say this is going to be Ang. So that means I need their name to be Ang. Now, this might look like it should work, because this would work if it was, say, a number rather than a string, but a string is an array, and you can't just dump an array into an array like that. I mean, if you've seen the slides that I had before, you'll see that I used something else other than an equals here. Yeah, so we can't just say an array should be equal to another array. We need something that actually goes through and takes it character by character and copies it in. Now, we have a nice way of doing that, and I'm going to grab that from one of the standard libraries instead of having to write the while loop myself. If you want to write a while loop that copies characters from one string to another, I feel like that's an interesting exercise and something that you can look into if you want to, because the interesting thing about that is the stopping case. So you have to check for the null terminator for the stopping case when you're copying strings to strings. But for the moment, because I want to do other work on things like structs and pointers as well, I'm going to let my string.h deal with that for me. So string.h gives me access to a function called structs. This is like the dumbest name for a function that is left over from when we didn't have enough characters to really say things properly. This is string copy. So string copy is going to take 2 strings, and it's going to copy the second string into the first string. If I remember, it is destination first, then source. If I need to look this up, where are we? Actually, I don't even need to look this up on Google, although it is here in Google. Destination, source. I can look this up, places like this. Or I can hop across my terminal here and say manual for stir copy, and hopefully it will give me this information. Yes, in order to use this, I need to include string.h. That's cool, I knew that was there, so I did that already. Stir copy says destination first, source next. Don't worry too much about all this other stuff. But remember that when we're looking at pointers and arrays, I said that you can, to a certain extent, interchange the use of a pointer and array. So this is a pointer to the first character in the array, and then I could give it the array itself as the variable, and it would have the address of the same thing, the pointer that points to the start of the array. Okay. So I'll just quit out of that and go back to my code and say, if it's the destination is the first thing that I put in there, and then the thing that it's coming from is the source, which is the next thing that I put in here. So the first thing is companions 0.name. So this is a string because I know that inside any struct bender there is a string called name. So this accesses the array, first array element, and it says this is a struct bender, and I say .name accesses the name inside this particular bender struct. So I've gone into the first bender struct and said I'm going to copy something into your name. And I'm using the way that we were talking about before, the value of, the possible value of a string here. So say copy these 4 letters and a null terminator into here, so that now if I go in and I look at companion 0, I'm going to get ang as the name. So this is slightly different from me just doing an equals. This is me using a string copy to do that. So we're going to do another string copy because we have another a word, I guess, in here, which is the element. So companions 0, so this is also the same person, ang, element. So this is the destination of the thing that I'm copying, and then the source that I'm copying from is going to be here. I'm going to go with air. I was tempted to say something like all, but I'm just going to start with air, and we're not going to. Am I spoiling this already? I think I'm spoiling stuff already. I'm going to stop spoiling stuff. Ang's just an airbender. There's nothing else. I don't know who that is, but I'm sure that got into the microphone. The dot before name means I have a struct bender here. So this is a struct bender because it's one element of the array. The dot says, please go into the struct. So we go into the struct and we want to access one of the things that exists inside the struct. So every one of these structs in this array, each one of them has a name, an element, a power, and a health. Let me show you a little bit about how a struct works. So my bender is here, and it has an array. Try to go fast and things just look messy. Another array. So this is the name. This is the element. And a couple of integers. You're not going to have this empty space here in a struct normally. It just packs itself into memory in a nice way. We don't really need to worry too much about how these are laid out in memory, because we're not kind of addressing these things directly in memory. If we're going to use them, we're going to use them by name or by pointer and stuff like that. So here we've got name, element. I'm not going to spell all that out while I'm writing with my mouse. And here we've got power, and here we have health. So when I come to the bender, that looks like bendin. Oh well. When I come to the bender, I can access part of the memory that the bender has by saying .name will give me this array here, .element will give me this array, .power will give me this integer, .health will give me this integer. So if I want to access one of the fields inside the array, I use the dot. to get to that field. And so that way I can go in and go, okay, I want to access this string because I want to make changes to this string. I'm not interested in making changes to the other parts of the array. Sorry, the other parts of the struct at this point. And so if we have multiple benders in a struct, we'll have multiple copies of this box here. And so each one has got all these elements inside it. Okay, so I've set up the two strings inside this one bender, and then I will set up the integer variables as well. So companions 0, because I'm still setting up the first companion. Power. I think that Ang is very, very powerful, so I'm going to give him a 9 on power. I'm keeping the numbers low, like maybe out of 10 or something. Let me just remember how did I... Oh, I gave him a 10 before. Right, okay, fine. Ang can have a 10. Most powerful bender. His health, however... I don't recall him being, you know, super survivable or anything. He was reasonably, but not super survivable. So we're going to keep his health low, but give him a lot of power. He's that kind of guy. And then I'm going to go through and fill out the team with this similar kind of information. So what I'm going to do is I'm going to do a bit of slightly dodgy copy-paste for these. Who did I do next? I assume it's going to be Katara. Yes. Alright, and she has pretty average stats because she knows what she's doing. She's definitely tougher than Ang, but not necessarily as elementally powerful. So, Katara here is going to go in the next slot, so I'm going to change all of these to 1s, so I'm affecting the next person in the team. Sam is saying, what season is this? Because 10 is very high. Yeah, so I think I'm at about season 2 because I've got 4 benders here, so Toph's going to be involved as well. I still think even at that point, I think he was still more powerful than any of the others in the group. I think. But I still kept him pretty fragile. So we're not going to... We're not going to discuss spoilers. So, because we're not going to discuss spoilers, I am not going to enter a discussion into Aang's power. He's just a kid. He's just a kid who can airbend. Okay, so Katara's a bit tougher. She's a bit more worldly. She knows what's going on. But her magical abilities are not at his level. Okay. Sokka is the funny one, because he is Katara's brother, and so he's going to go in the next bender slot. And he may be from... Oh, wait. I forgot. Katara's a waterbender. So Sokka is the third here, Katara's brother. He is from the water tribe, but he does not know how to bend elements, so he's going to have a none for his elements. And Sokka, I think, holds a very dear place in my heart, because he has this particular ability to not generally have a huge amount of effect on what's going on, but in the general scheme of things, his ability to just soak damage during the course of the TV series is nothing short of legendary. So he was the one who just kind of got hurt in every fight. People are saying that we should make the exam about this. We're not going to make the exam about this. Maybe there'll be some theme in some of the questions, but I'm not. I do have to understand that a significant percentage of the people in this course haven't necessarily seen Avatar: The Last Airbender, so this is something that I'm not going to test you on. But sometimes things will have themes in them, as you can tell, because I did stuff with dice and with other things. So it's still quite a possibility. Okay, Toph is the other. I wonder if I had stats for them in here. No, I didn't. Okay. So Toph's going to be the last, and we're going to use the same kind of setup for her. She was an earthbender. Well, still is. I actually don't know. I don't know what the time period is. I say was because I haven't watched it recently. If I was watching it right now, if I was watching it again, I would probably say is. Now, point of contention here is Toph more powerful than Katara? I don't know. I think that they're reasonably similar, but I might say that Katara is just a little bit more powerful than Toph, but I feel like Toph can take more of a beating. You know, I feel like as an earthbender, she has more capability to take a hit and to shield herself and stuff like that. Whereas Katara, I think out of the group, she's like the average. She has reasonably good bending and reasonably good capabilities. I love it. People are like, we're here to learn about programming. Why are you just explaining everything about these characters? Okay, so we've got our team now, and our team has different statistics, and they have different information, which means that this array of bender structs now has all its information filled out. So with all of its information filled out... Yes, Francis, I did not give Sokka an element. And that was because he has no magical abilities, and this is why his power is so low, but his health is high, because he eats it all the time. Okay, and even from the others, sometimes they even beat him up just for the fun of it. Okay, so this is our stats for our team, which means all of the memory that was assigned to the companions in this array now has all of its values filled out. So all the data is in that memory now. There's some empty memory in there because these strings up here are 100 long, and we're only using the first few bytes of them, but that's okay. You know, when we're using strings, we don't have to fill up the array of strings, because crucially, at the end of each of these, in these strings here is going to be the null terminator that says there were no more characters to this string. You don't have to read any further. Okay, so that's full. And now we're going to have another bender, which is our enemy. And that's going to be... James is asking something. When I write struct bender companions, what does bender do when I'm declaring something like this? So this is a good question, because it's good to think about what these keywords mean to us in C. So when my compiler reads this and says, what did the human mean when they said this? The first thing they see is struct. So the struct says this was going to be a human-made variable. The human has said that somewhere else in the code this struct is defined, and it's defined under the name bender. So it'll look elsewhere in the code. It's easy because our code is a single file, and it's right here. We can see struct bender. So we go, okay, they meant that variable. So they exactly meant this variable. This variable is now a type. So struct bender is a type, and so companions there is an array of type struct bender. So this is nearly like you'd consider a single word, in this way that we have int or double or char. They're variable types. Struct bender as a pair of words is now a variable type, and the variable type is saying, because it's a struct, you need to refer back to somewhere else where this struct was defined, and then you'll know what it's supposed to be for this array. So this struct has a very specific size in memory, in the same way that an int or a double has a specific size. The thing that happens even more than that is the struct has kind of different sections in its memory that mean different things. I mean, an array also has different sections in its memory that are different variables, but they'll all be the same size because they're all the same variable type. The struct can have different variable types inside it, or even multiples of a variable type inside it. So it's 100 characters worth of space in its memory, another 100 characters worth of space in its memory, 32 bits of integer in its memory, and then another 32 bits of integer. If we wanted to go through and add up all those numbers, that would be like 800 plus 800 plus 32 plus 32. That's exactly how many bits of memory struct bender takes up. Hopefully that answers your question. It's not a dumb question, James. It's definitely not a dumb question. I've seen this question a lot before, because what we need to do is we need to get our head around the fact that we now have a variable type that is not nicely highlighted in green for us and is made up of 2 words instead of 1. So I think it's still quite a good question. Yes, companion's team size is declaring an array. So this is declaring an array in the same way that this isn't actually declaring an array, this is saying that array is in the struct, but in any other way we could declare an array like this by giving it a name and a size in square brackets. But an array has to have a type, and the type is struct bender. So we have 4 benders in the array, and then we fill them out with this information here. So Prince Zuko is also a bender. Here comes the power of structs, in that the teammates and the enemy are the same variable type. They don't need a different variable type even though they serve a different purpose. So I could use an integer as a counter for a loop. I could use an integer as a score in a game. I could use an integer as the number on the face of a die. That's all very different purposes, but I can use the same variable type for them. The struct bender is a variable type I can use for things as well. So, struct bender, I wonder what name I gave it. Here it is. Oh, I just called it Zuko. That's fine. Yeah. Ha 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 ha. Humza Said says, we should do a Pokemon battle with C, lol. I don't know if you know this, but the second assignment last year for I think more than one of the terms we used this last year was actually a Pokedex. And so we literally did have Pokemon in structs. So we had structs defining Pokemon, and then we used them, and then we tracked their evolutions and stuff like that. We're not doing that this year. Well, obviously we're not, because I've just given it away. But I'm not going to repeat the same assignments too many times in a row if I can help it. So unfortunately, you're not going to get the Pokemon assignment. But we're going to do something else, and it'll be interesting nonetheless. But yeah, we have in the past used Pokemon. In fact, there's definitely either a lab exercise or a weekly test that I wrote last year that definitely uses Pokemon. I can't remember when it happens, but somewhere it'll be in there. Maybe. I don't always reuse exactly the same things from previously, but I've written one in the past that was like using pointers to do Pokemon evolution. That might actually be an interesting one for the labs next week. We'll see how we go. Not promising anything, but we might have some Pokemon in the near future. Anyway, so new variable, struct bender Zuko. So this time we're doing a single variable as opposed to an array of them, but it's the same thing as declaring a variable. So I could say int Zuko, but instead I say struct bender Zuko, and so now Zuko is a variable that is of type struct bender, which means inside the variable for Zuko there is a name string, an element string, a power number, and a health number, integer. I shouldn't just say number, I'm going to be clear on those things. So I should now assign those values so that they can be used for things, and it's going to go similarly to this. I'm going to copy that same thing I've been using, but instead of this being one of the companions, it is now Zuko. This is Prince Zuko. Prince Zuko is a very, very powerful firebender. To make this interesting and make this a boss fight, I mean, Prince Zuko was quite happily able to take on all 4 of them at once. So I think Prince Zuko is going to have stats that are a lot higher. I remember what stats I gave him last time. Whoa! Okay. Alright, past mark. You and you're making Zuko OP. Zuko is going to have 20 power and 20 health, because he's a badass, and, well, he hurt them a lot in different ways. Again, spoilers, I apologize. I'm not going to say anything more. He's powerful. And in our fights here, something might happen. It may be the same or different from the fights that happen in the show, but I will, again, try not to give away spoilers about the show. James, yeah, all past me. So, this is the 4th time I've taught COMP1511. So, in a previous iteration of this exact example, there's a reason why there are 4 of them here and 1 enemy. It was the 4 Ninja Turtles versus the Shredder. So that's me really pushing back the clock a bit to the things I used to love as a kid, because I think the Ninja Turtles have aged a bit, and I don't think that one resonated as much as Avatar. I didn't expect Avatar to like really resonate with so many people, but it did, and that was a nice thing. So you're lucky because you're getting this recycled. I was going to do something new, but even recycled, people are liking it, so that's fine. Okay, so now in my memory of my program, I have an array of 4 benders, and they have some information in there. These happen to be characters from the TV show. And then I have a single bender on its own, and it has its own information here. So now that we've got this information, we can start to think about what... Future Mark is going to talk about Present Mark the same way. Future Mark is going to talk about Present Mark and go, my god, Past Mark had to take his entire course online in week 5, and then in week 6 he had to change all his assessment from the normal numerical assessment to pass-fail. And I remember Past Mark being the tiredest version of Mark that ever existed. It's even worse than the other Past Mark that tried to rewrite the entire course in one term. That was not a good idea. I will never do that again. So I should always recycle some part of the course, because if I try to rewrite it all in one go, there's just not enough time in the week to write that many lectures and tutorials and labs and weekly tests. Yeah, but the super meta thinking about your future self, thinking about your past self. So yeah, but it's going to happen. Your future selves, I really, really hope that your future selves will look back on this and go, do you remember that time when UNSW had to shut entirely because there was a pandemic and stuff? And then, like, you know, eventually we got back on campus and everything went back to normal, and we kind of, like, we sorted everything out. And I hope your future selves will be able to look back and go, that was a rough time. It was a rough time for everybody, but we all got through it together. And that made us happy. So it's okay, because we all got through it together. And I hope that we do. I don't know. I can't offer any promises. This virus has killed a whole lot of people around the world, and I hope that things go okay, but I have no... You know, like, my heart says I hope things will be okay, but my head says, nah, things are not necessarily going to be okay, so we're going to have to do the best we can with the situation that we're in. Which is what we're doing now. We're learning about structs, and we're thinking about Avatar, and I hope after this stream everyone goes and watches some Avatar, because it's a lot of fun. Or you can do your assignments, because I also have thrown deadlines in front of you as well. I forgot also that the weekly test was due like halfway through this stream. So I apologize anyone who was like frantically trying to finish that in time. But I mean, like, you know, we've had some time to do it, and we didn't have any labs this week, so hopefully there was enough time to do that, because you didn't have to spend time on your labs. Okay, so we've set up our data. Having set up our data, we want to put some functions in. So let's have a function for a single attack. And a single attack is going to take one bender as the attacker, another bender as the target, and it's going to alter the target's health by however much the attacker's power was. And so in order to do that, I need access to the memory for the attacker and the defender. So this is why the attack function is going to have a pointer to the attacker and a pointer to the target, and then it's going to do some work in there. We'll have a look at the work in a second. Okay, so making a new function. New function's going to come up here. So usually we put our functions after our structs. I wonder if I had a result. No, it's just a void. Void attack. and struct bender attacker. Now, remember, I've said before that if I give a variable to a function, it's going to make its own copy of that variable inside the function itself, and any changes we make to that are not going to reflect in the actual benders that are there. I don't want that. I want to use the actual benders that are here. If I want to use the actual benders that are here, I just want pointers to them. I don't want copies of them going into the function. I want them to be characters in themselves. I don't want a clone of Aang in here doing the attack. I want Aang himself doing the attack. And I don't want a clone of Zuko either. So if I want to be able to change their health because they've been the result of an attack, I want to be changing the ones that are actually in the array or in the program, and not the copy of it that goes into the function. I'm going to talk more about this next week as well. I'm going to go into a little more detail about the memory that is in functions. I've mentioned it before, I've talked about it before, but it's the kind of thing that I think, it's not the kind of thing I only want to say once, right? So I'm going to keep bringing up things that I think take more time to learn. Humza's asking to explain what the difference is between something like string copy and using the equals. Let me just finish the definition of this function, and then we'll go back and have a look. So struct bender target, except I don't just want a copy of the variable, I want a reference to the variable itself. So I want to go, here's the memory where that struct is, now you can use stuff. So we've got these two things here that Holmes is asking about there. So one of them is string copy, which says that I have a field inside my struct, and I want this field to be equal to this string. Equals doesn't work with strings because they're arrays. You can't just go, the one array equals another, and expect all of the elements of this to be copied in to that array. So instead, I'm using a function that helps me out called string copy, which is made to copy one string to another. So this is like saying, I want this string here, companion 0.name, to be equal to Aang. I use this function to do it for me. When I'm doing it here with the equals, that's me just assigning a value to a variable, which I can do with something like an integer. So the only reason I had to use string copy is because you can't just take an array and say an array equals the value. The only time you can do that is when you first create the array in initialization. And when you initialize these variables in here, we can't really set them up with information from this point. Because they're all going to have very different information. So normally with an array, if I wanted to, I could do an equals, curly brackets, and I could put some values in there. But that doesn't really work with structs. Hopefully that's enough to answer your question. Okay, so this function is going to make one bender attack another. A single bender attack. The target's health will be reduced by the attacker's power. Okay. Let's write this function. So one of the first things that I did with this was to make it exciting. In order to make it exciting, I wanted to print out some information about what was happening. So I've got some information here. Someone attacks someone for a certain amount of damage. This is nice because if this is like a game or something like that, we want to know what's happening. So somebody with the %s allows me to have a string, attacks somebody else for a decimal integer amount of damage. And we'll put a new line on the end so that each thing just comes up for one line on our screen when we're showing it. We're going to have some information there. I might push this down to the next line. Oops, I didn't need to indent that. Push this down to the next line so I can put my three variables here. Okay, so the first one is the name of the attacker. So that's going to be... Did I have an extra space there? I did. I'd like my indentation to be 4 spaces. lots of extra spaces there. So my attacker, and I want to access the field for the name inside the attacker. So the attacker is a pointer. Remember, the attacker here is a pointer. It is not a bender struct, so it's not a variable. It's a pointer. So we are going to use this new notation to say, take the attacker, follow its pointer into the struct, following its pointer to the struct and then into the struct to get the name. So this arrow thing says the thing on the left is a pointer to a struct. The thing on the right is one of the fields inside that struct. So the arrow is different from the dot. The dot says this thing on the left is a struct. The thing on the right is something inside the struct. The arrow says the thing on the left is a pointer to a struct, and the thing on the right is something inside that struct. So we're going to use the arrow and the dot differently depending on what's on the left-hand side. Is what's on the left-hand side a pointer to a struct, or is it the struct itself? So if it's the struct itself, it has its variable name like that. If this variable name, attacker, has been declared as a pointer, as it has, because it's got the star, then you can't use a dot on it, because it's not a struct. You can't use a dot on it. You have to use the arrow to go to the location that the pointer is pointing at, and then grab one of the fields from inside it. Francis, %s is one of the printf things that is happily able to take a string. So before we did %c for a character, that was able to print out a single letter. %s allows us to print out the entire string. So it's just a convenience thing, as opposed to us, say, doing a while loop through attacker name and printing out the letters one by one. %s is able to just do that for us automatically. Okay, so we've accessed the attacker's name, and that's the first variable. And then the target's name in the same way. Target is also a pointer, which means we can't use the dot, we use the arrow because it's a pointer. And for a certain amount of damage, and the amount of damage is going to be the attacker's power. So it's the attacker, and again, the attacker is a pointer, so we've got a pointy thing to access from a pointer. I wonder if that's a good way to remember that. It's a pointy thing accessing a pointer, and it's a dot thing to access the variable. That doesn't make any sense, but the pointer thing does. For their power. Okay, I'm just going to save that. So this means that if I have a bender attacking another bender, it's going to tell me who attacked who and for how much damage. The next thing that we're going to do is we're going to apply that damage to the target. So my target has its health reduced by a certain amount. I'm going to show you a way of modifying variables that I think I skipped in my slides earlier on. You can do this thing called plus equals or minus equals. I can't remember whether I actually explained this or not. Plus equals or minus equals says just change this variable by this much. So if I say target health minus equals attacker power, what I'm saying is take whatever number is in target health, and then whatever number is in attacker power minus the attacker power from the target health, and then store the result back in the target health. So this minus equals is just saying reduce this one by this much. So for example, if I have 10 minus equals, actually let's just say, if I have int x equals 10, and I have x minus equals 5, x is now equal to 5. I'm going to change those numbers to make it more readable. Yeah. So if I did minus equals 3 on a variable containing 10, the variable would then contain 7. So this is just a shorthand way that we can make changes to variables. There's a plus equals as well. Does the same thing. Well, not exactly the same thing. It adds instead of reduces. Clarify something about pointers. If I declare int a, then is pointer a hexadecimal? Or if you declare int pointer a, then is a hexadecimal? Maybe I'm just confused about everything. So, for Paris's question, if I declared, let me just bring them back, int x, then int x is 32 bits of memory, which is encoded in a way to store integers. That doesn't make it hexadecimal or not hexadecimal. So if I want to, I could print out x is equal to 10 and use, I can't remember exactly which pattern, one of the percent patterns to show it as a hexadecimal number. Tom will know it, or Tom will look it up quickly because he knows I'm talking about it. He'll be able to tell you which pattern it is. So an integer could be displayed as a hexadecimal number. It could also be displayed as a binary number. We happen to use them a lot as decimal numbers because that's how humans understand them. If I have something else, like int star x, oh no, I can't call it x, px is equal to the address of x. So this is like create a pointer aimed at x. If I have a pointer aimed at x, this thing has an address. The address is a hexadecimal number. I mean, but it's just encoded as an integer. You could actually print it out as a decimal if you wanted to. But this thing will store the value of the location of this one. And the value of the location of this one is an address, which is usually a hexadecimal number. Hopefully that's is a little bit of information for you there, Paris. Yeah, Tom knows what the hex number is and the pointer thing is as well. I don't usually try to memorize a lot of those little things like that. I look them up instead. Simply Me is asking style here. I'm going to delete this stuff because it's not part of our code. Style here, if aligning this with the opening bracket and leaving the closing bracket at the same time, stylistically okay. Yeah, if you want to. So some people do it like this. Which is fine. This is just splitting the line. I did it really specifically because sometimes when I have brackets, I want to be really clear where they open and close. So if I have an open bracket that doesn't close on the same line, I like to have it vertically aligned below. When it's vertically aligned below, I can scan my code and I can see where it opens and closes. So to me, this is okay, but this is a little bit clearer about exactly what's inside that printf, because I can scan it vertically and I can see where it closes. It's not too bad to do it the way that you did it, and when I do it vertically, I follow my strict indenting rules, so I use 4 spaces for the indent each time. So it can be nice to line it up with the brackets, but I like it to be consistent. So I like all my indenting to be consistent. So if I'm scanning without really reading it, so I'm not even reading the words, I'm just scanning the indentation level for structure, this thing is clearly inside these brackets because of the way the brackets are laid out and the level of indentation. So that's why I did it this way on instinct. I don't think it's like entirely wrong for you to leave it all on one line, but I do it this way because I'm used to doing all of my brackets the same way. So if it doesn't close on the same line, like something like this does, then it closes directly below the indentation level of the line that opened it. Tom's asking if I would also keep the string on the same line as the open bracket. So sometimes I will do this. So sometimes if I want to be like super specific, I will do this. So there's an argument back and forth on this. Like, one, I'm taking up a lot of vertical space, which some people don't like. But the other thing is I can now read this vertically and I can see everything really clearly. I can see there are 3 variables. The way I had it before I do that, I can't see for certain that there are 3 variables when I scan. When I just kind of like speed reading through my code, I'll be like, yeah, printf with some variables, and I won't know exactly how many there are. So sometimes I'll do it vertically because it'll be like exactly 3 variables, you know, so you can see how that speeds up the reading of it, which might help you with problem solving because you might have, oh, some of my variables aren't appearing. What's going wrong? and if you had it laid out so that you could really clearly see how many there are, you could see that maybe there was a mistake, that you left one out, or you put one too many, or something like that. So you can see how, if we wanted to, we could do it like this, and it becomes super clear. First line I can see is the string, and then each one of these I can see exactly how many they are, and I can kind of read them vertically like that. Simply Me is saying, is nesting an issue if you do the indentation in the printf and it happens to be 5 indents into the code? Potentially. Yeah, potentially an issue. So if it becomes an issue, then potentially parts of these things need to go off into other functions, rather than all being in that one particular function. Whether that function is your main or another function, splitting things up to make it easier and clearer is something you can do. So for example here, I've got my attack here. This is a single attack. The way I'm going to be doing my attacks in this program is I'm going to have the two people attacking each other, and then a loop of them attacking each other. And if I did that all in my main, the indentation would be massive, because it's inside a loop, and then the pair of the attacks are separate, even though they're exactly the same code and stuff, so they'll be indented as well. And then this stuff in here will be indented, and things will get messy. Yeah. Paris is saying, can you make a while loop within the condition of an if statement? I want to say no. I'm pretty sure the answer to that is no, because the if statement's condition needs to have a result. It needs to give us an integer value that we can read as a true or false, and a while loop does not give a result. You can put functions in there though, so you could put a function with a while loop inside it, so long as that function returns something that the if statement can read. So it is kind of possible to put a while loop inside an if statement. So if I had an if statement that said, if all of the values in an array are even, then do something, I could say if, and make a function called if even, and inside that function there's a while loop, but the function itself returned a true false value for whether all of the elements were even. Then we could put that as the condition in a while loop, so the function that can return a value. But since the while loop is not actually an expression, it's not a code expression that evaluates into a value that we can check against, it can't be the question in the while loop, in the if statement. Sorry, I should keep coding, because we're actually reaching the end of when I was going to end the live stream, but I haven't actually done that much of this coding yet. So we're going to speed this up a bit. I'm going to keep going. I'm happy to go over time for live streams, no big deal. So we'll keep going for a little bit, and I'm going to explain things a little bit less and make sure this code actually comes out here. Okay, so what we have here is we're printing out what's happening to my user, and then I'm saying make the changes to the target's health, and then the next thing I was going to do was check if the target has run out of health. So if target health, now that it's been reduced by the attacker's power, is less than or equal to 0, that means the target is knocked out. So if the target is knocked out, what are we going to do? And I think we were going to print out something. We're just going to print out that they've been knocked out. Yep. Has been knocked out. And the string that I want there is the target's name. Okay, so now we have a function that can have two people attacking each other, or just one person attacking another person, and it will report what it is and then what happens. So if we want to, we can just try this. I'm going to try this with an obvious thing. I'm going to call this function. I'm going to make Zuko attack. I'm gonna attack Soccer because he's the one that always gets attacked, and that's funny. So he is companions 2. Alright, so what I've done here is I've just put these variables in here. Those of you who are watching carefully will know that this will not work because I have given struct benders to this function instead of pointers to struct benders. So a pointer to a struct bender is the address where the bender exists. So if I want to give the address to this function of where this bender is, I can put an AND in front of this that says give us this address. This is like me saying, would you like the value of a pointer to Zuko? That is the address that Zuko sits in, and that can be made into a pointer here, so I can take the value of the address of Zuko and make it into a pointer. So this is just like me saying something like struct bender pointer attacker equals the address of Zuko. This line here, creating a pointer that points at a particular variable, is kind of what this thing does when it starts running and it gets given that address. Alright, I'm going to get rid of that. It's not necessary. Yeah, so this is going to have Zuko attacking Sokka. So let's have a look at this running. And we're just going to compile it first and see whether this works. Okay, so I'm going to clear that. DCC benderfight.c output file. I'm just going to call it benderfight as well. Oops. Error. Passing struct bender to parameter the incompatible type struct bender pointer. So take the address with AND. Oh, that's exactly what I said I was doing, and I only did it for one of the two variables. So this is also a struct bender, but I needed the address of it. So it should be an AND in front of that. And me saying the address of a variable can be passed in to a pointer input to a function. Because a pointer input in the function requires a memory address, and the AND in front of any variable will give us the address of that variable. So then these things match up. Sam's asking about the clear command. I literally typed in the word clear, C-L-E-A-R. What that does, like so. Sorry, I pressed enter before the stream even picked up what was happening. I'm so fast, lightning fast coding. The clear there is going to do this. It's going to say, all right, nothing else on your terminal, so it's a little bit easier for you to see which bits you're doing at that time. Yeah, so now I'm going to do my compilation again and see if it works this time. It did work this time, so let's see if benderfight will run. Prince Zuko attacks Sokka for 20 damage. Sokka's been knocked out. Oh, again? Okay, so we know, because we know how much health Sokka had and how much damage he just received, that he got knocked out. I think I'm pronouncing that right. I always called him Sokka, even though it's spelled S-O-K-A-A. S-O-K-K-A, yeah. Alright, so we're reasonably sure that that's working. At least everything inside this got to run, and it gave us some information like that. Okay, so we've got a single attack, and we've talked about passing addresses into functions, and we've now done some tests of calling the attack function, but what we can do... Oh, this is slightly... Oh, yeah, so we've done this point here. We've done the address of those things. And if we wanted to use pointers to them, we could create those pointers and then use those pointers in the attack as well. So this is kind of everything that I was talking about there. Strangely enough, my slides follow my thought processes in teaching these things. Okay, so let's fight until one side loses, which means what we're going to do is we're going to loop through and have these fights. So we're going to add some simultaneity to these fights so that they both hit each other at the same time. So Sokka's not just going to get KO'd immediately. Any attack pattern that we have is going to go both ways. So there's a chance that if Sokka could magically do enough damage, which he can't because Zuko is like super strong, he could also knock out Zuko at the same time. So we're going to have attacks go both ways at the same time. This is going to be one single attack. So what we're going to do now is we're going to loop through, and while looping through, we're going to continue having the duels. So everyone's going to only have a duel at a time. So the duels happen, and each time a companion gets knocked out, a different companion is going to step in and take over until all of 4 companions are either knocked out or Zuko is knocked out at some point. So we're going to need a whole lot of work in here when you think about this. I need people to fight, but if someone gets knocked out, I need to now move on to the next element in the array, and it will fight until someone's knocked out. But if at any point either the whole array is knocked out or Zuko is knocked out, then the fight should end at that point. So there's a lot of little ingredients that's going on here. So a loop that keeps the fight going, and then lets the companions step in anytime one of them is knocked out. So what we're going to do is have a function called still alive, and this still alive function says that the fight should continue. It's only going to return true if both sides have someone left to fight. If either side doesn't have anyone left to fight, so Zuko on his own gets knocked out, or all of the benders get knocked out, then at that point still alive should return false. So I've got a function here for still alive, which is going to be checking whether everyone in the team has health or not, and whether the solo bender fighting them has health or not. So let's make this function. Still alive, and still alive is going to check a solo fighter, and it's also going to check a team of fighters. That team is going to be team size. I just flipped my S and Z. Okay, so remember, when I pass an array into something, this gives me access to the array. So I don't need to put a star in this because I don't need a pointer to the array, because me passing in an array is actually giving me an address to the array itself. So it's just a little bit of like terminology that's slightly different there. It's kind of like the name of the array is a pointer to it. It's not exactly that, but it's like that. Okay. So making this function here, are there combatants on both sides still able to fight? Maybe I'll put more detail in there. Return, oops, too many spaces. 1 if yes, 0 if no. Okay, so still alive is going to check 2 things. Oh, it's going to check multiple things. It's going to check the health on both. So if the health of any of them drops to 0, then it's going to return that. And I did some funky coding in here to get this working. So I had 2 integers, solo alive and team alive. And then I started these at a 1 and a 0 because I could change them under different conditions. So let's just look at the solo alive first. Int solo alive, int equals 1. So the solo person is alive unless their health is below 0. So if solo health, so solo is a pointer to a struct bender, so it depends on who I pass into this, but it's likely going to be Zuko. So if their health is below or equal to 0, then they are not alive. And if they're not alive, that should be 0. So S alive becomes 0. Too many spaces. Solo has been knocked out. Okay. So this is enough. If I was going to do this, oops, this would, if I did it like this, return whether this person is capable of continuing the fight. So most of the time we return 1 unless this check, is true, that its health is equal to or less than 0, then it would become 0. So this is going to return the status of the solo combatant. But that's not the only thing that we're going to do. We also have the status for the team, and I called that T alive. And I started that one off at 0 because there was a condition under which this would change. And now I need to loop through my array of the team and check all of their health. And if any of those is greater than 0, then T alive becomes 1. But if I make it through the whole loop and don't change T alive, that says that I found all of their health was below 0. I could start this at 1 and flick it to 0, but I'm going to start at 0, flick it to 1, because it sort of makes sense to me. So int I equals 0. I'm just going to use I for this loop. And it's a while loop. And while I is less than team size, bog standard looping through an array, right? It just so happens this is an array of structs, but that doesn't change the structure of how we are going to loop through. So bog standard while loop up to a number with a counter that goes through. This will allow us to check everything in team. So I've got an if statement here, which is if team I, this gives me access to one of the benders, and then I'm going to look. Are we? Yes, no, we're accessing the bender, not a pointer to the bender, so it's a dot. Team I dot health, because this is not a pointer, so it gets a dot. This is a pointer, so it gets a pointy bit. I wonder if that helps. I think it might be helping. Yeah, so if that team member's health is greater than 0, that means that no matter where I am in the team, that means someone in the team still has health left. Team member still has health. And I'm going to say here, just to remind myself of where I am in the loop, have checked I team members. So it's like, when I start the loop and I is equal to 0, I know I have checked 0 members. When I'm at the end of the loop and I becomes equal to team size, then I know I've checked all 4 team members. Okay, team I health is greater than 0. That means a team member still has health. If a team member still has health, then the team is alive, because the team only needs one person left to fight, to be able to fight. If I want to, I could stop the loop here, but this is not a construct that I generally teach, because it's not something that I necessarily need to teach. If I had an exit flag here, I could say exit equals 1. Some people may have seen this before, which is break. Break exits the loop. I'm actually not going to bother, because I don't mind, especially with a loop this small, if it just goes through and it maybe tries to set T alive more than once. That's fine. We're not worried too much about cutting things off for efficiency or anything like that. Okay, so team health is greater than 0 for any of them means the team is alive. So now I said I want to return S alive, but I also want to return T alive. They're both either going to be 1 or 0. So the cool thing that I can do here is I can multiply them. S alive multiplied by T alive, which means if both teams are alive, it's equal to 1. If one team is alive, then the other one is going to be equal to 0. That's going to make this 0. This is nearly like also doing this. This will actually have the same result for 1s and 0s, where if they're both 1, then this is going to return 1. If either one of them is 0, this is going to return 0. I'm actually leave this as and, because this makes this a logical thing. If the solo is alive and the team is alive, then we're going to continue this fight. Alright, no questions there so far. So that's what all that code is doing. I might just check solo bender, and here check that any of the team is alive. I mean, they're never really dead. Like, we're only like knocking them out in these fights. There you go, still fighting. Okay, so this still alive allows us to, for example, put a function in a while loop to say that still alive has to be true for us to continue this fight. And this is exactly the kind of thing we're asking there is, can we put a while loop inside an if statement? This does have a while loop in it. Still alive is definitely a good function for an if statement because it returns a true false for the we should continue the fight. So we actually do have a situation where we're going to do something in an if statement that had some looping in it. But we can't just put a loop in. We're going to put a function in that returns something. So back to our main here. After we've set up all that stuff, I'm going to put this above this because this single attack action is probably going to disappear pretty soon. I can have a while loop, and in that while loop I can say still alive as a function. So the question inside the while loop just had to give us a 0 or a 1, not even a 0 or a 1, any value or a 0. And then we will be able to use that as the question in the while loop. So we've set up this specifically to say keep looping while someone's still alive. And so there's a pointer to the solo one and then the array of the team. So the pointer to the solo one is the address of Zuko. The second thing is the team, which is companions. And I'm not putting any square brackets because I'm giving the whole team, not just one element of the team. Simply me is asking, why is it T alive? Why is it S alive and T alive? How can variables be true? So variables can be true or considered true from a C perspective if they have a value that is not 0. If they have a value that is 0, they're considered to be false. So this thing I'm doing here with these 1s and 0s is I treated these integers like they were kind of true-false values, which means I could put them into this AND statement here. I mean, I probably should compile this to make sure I've written this correctly, because I just made a change here. But I'm pretty sure this is going to work, because I've got a 1 or a 0 on either side of an AND. That is going to equate all of that down to a single 1 or 0, because it's going to combine them both together in the AND like that. Jackson is asking me, can we get a function to return 2 separate values? And if so, how do we access a specific one? We cannot get a function to return 2 separate values. The nature of functions is when they run, in a sense, where they were called in the main or in another function, that the line that calls them will basically be transformed into the result. So they'll be transformed into a single variable that's a result. However, if we want to make changes to more than one variable, we can use pointers such as this. So I'm not actually making changes to the attacker in this one, but I used a pointer anyway. This gives me a pointer to an attacker and a pointer to a target. And if I want to, I can make changes to both of them in here. And these would make changes to the memory there because these pointers are giving me access to, because they're pointing to memory somewhere, they're giving me access to that memory. So yeah, if I want a function to give me more than one piece of information, I can give pointers to that function and set up the memory where I want that information to be written to somewhere else. Okay. So, Simply Me is enjoying my use of integers as true-false values. They've been integers all along, actually. They've always been integers. If this makes you want to go back and do the order 3 challenge exercises, you can do that, because this is actually the trick to doing it. Everything that we were doing with true-false was giving us numerical output, which means this, the double and multiplying this was going to give me the same result. But if these were numbers other than 0, multiplying would give me more interesting results. But anyway. Yeah, Tom's also saying if we wanted multiple outputs or something, we could return a struct. But then we'd have to define a struct as the answer to that function, and things, I mean, you can do it. You can do it, but things can get a little messy like that. Okay, so while still alive, this is happening. So what I want to do is say this is the main fight loop. So this is going to be happening multiple times. And every time the fight loop happens, it'll loop every time it's okay to continue fighting. It's only okay to continue fighting if both teams have someone to fight. So we want a single attack to happen each time the loop happens. Obviously, this is not going to be the same attack action each time, because if it was the same attack action each time, poor sucker would just get pummeled by Zuko, and no one else would step in on his behalf. So what we need is to make sure that we switch companions if someone gets knocked out. So we need to track, I'm going to say current companion. I'm going to start that at 0, and I'm going to use the indexes into the companions array as that. I wonder if I should do that. Oh yeah. Let's use the indexes at the moment. I was nearly going to use a pointer, but then that involves some other pointer stuff that we're not necessarily going to do at this point. So current companion is 0, which means that the person who's in the fight is the current companion. That's a little bit gigantic, a variable name. I'll leave it like that for now. I mean, I could have gotten away with just the word current there. I think people would have understood what I was saying. Anyway, single attack action between Zuko and the current companion. It's always going to be Zuko, because he's on his own and the rest of them are in a group. So we're going to loop through these, but the one thing that we haven't done is switch to the next companion if the current, oops, autocomplete by accident, is knocked out. So we need to be able to check if the current companion is knocked out, and if the current companion is knocked out, then we move on to the next companion. So we can check if the current companion is knocked out. I mean, we actually have some code here that is checking if the current companion is knocked out. So this if statement here is something that I would like to use. I don't know if I'm going to leave it in here in the attack. Maybe I will still leave this section in the attack, and I'm going to check it again out here. So if companions current companion, so this gets me the current companion, dot, because this is not a pointer, this is the actual struct itself. If it was in here where I had a pointer to the target, then it would use the pointy one because it was using a pointer. Because it's not using a pointer, it's using the actual struct itself there, it's not pointy. Now I'm going to teach that way from now on. I just made that up then, but I'm really happy with that one. Okay, it's not pointy, so it uses the dot. Their health is less than or equal to 0. Then KO. Then current companion goes on to the next companion. I have a risk here. A risk I need to be careful of, because if I'm going on to the current companion, it means I could move this index number off the end of the array. What I'm hoping is that if I hit a point where I've moved off the end of the array, then Still Alive should fail at that point, because Still Alive should see all of the companions as knocked out if I've moved off the end of the array. So I think I'm going to be safe there, but that's something that I need to just kind of think about and make sure that this thing is never going to tell me to access the array here with an index that's outside the array. And the way I have to check that is to make sure that this while loop will never run at the time that current companion has moved off the end of the array, because the only reason it could move off the end of the array is all 4 of them are knocked out. Okay, I've written a lot of code here that I should test. In fact, I should not have written this loop. What I should have done is tested whether this thing was working before I wrote that whole loop. Having said that, I've done it now, so I'm going to try it. So I'm going to compile it first and see where my syntax errors are, and then I'll run it and see if all of this is working correctly. I'm just going to clear all of these gedit errors here, and then compile again. Okay, I got lucky there. Syntax happened to be correct. It's not always going to be the case, as you saw last time. And I'll run Benderfight now. Okay, cool. We have a full fight now. Zuko attacks Aang for 20 damage. Aang has been knocked out. Poor Aang. Aang attacks Zuko back for 10 damage. So that means that Zuko's probably on lower health now. No one's actually reporting what health they're on, so maybe we need to do that at some point. Zuko attacks Aang for 20 damage. Aang has been knocked out. Aang attacks Prince Zuko for 10 damage. Prince Zuko has been knocked out. Oh, I've got a problem here. So I didn't have a syntax error, but I definitely have a logical error. I thought I wrote code then, which was going to change which of the companions was being fought each time one of them got knocked out. But Aang is probably going down to massive negative health here because Zuko keeps hitting him for 20 damage and hasn't moved on to the others. So if Zuko hasn't moved on to the others, then I've got an issue potentially in my loop or potentially in my current companion that is causing an issue here. So I've got my current companion. I was increasing my current companion when someone got knocked out. So someone can probably already see this, and someone's probably already typing an answer here, but I'm not going to go with an answer here. What I want to go with is a method with which we can find out what is going wrong. So when these attacks are happening, there is a certain companion. I need to know what's happening. So printf current is equal to certain number. I actually don't need any more information than that. I just want to know what current is to make sure that the right companion is going there. So I need to figure out whether this current, I didn't need the plus to have a space there, is increasing properly or not. And I know you can probably see this, and I hope that most people can see what I've done here, but I want to go through this anyway. So this is going to give me some information about what's happening. I also want to say printf here, main fight loop running. So I just want to make sure that I know each time this loop starts, and I know what the current is just before the two attacks happen. And I want to know whether I'm changing this properly or not. So maybe my test here was incorrect and I wasn't changing current companion, so I'm going to do a printf in here saying current is... Oh, I do know what current is. Oh, I'm going to check it here anyway, in case I've changed it by accident. Current equals D has been KO'd health %D as well. Oh, whoops. I need to actually put the variable there. Current companion. And here, I'm just going to go down to the next line. The first one was current companion. I need a comma to get there. I'm going to put this on a new line as well. Second integer was their health, which is this incredibly long thing. I'm going to put that on its own line because it's huge. Okay, so I know that some of you can already see what went wrong here, but what I'm talking about here is not just looking at it and trying to figure out what's wrong, is looking at how to get enough information out of these things so you can see what's wrong. Because there's always going to be times where you can't see immediately what's wrong, and you need to fall back to like getting this information. So I picked areas where I think this could be going wrong. So I want to know just before the attack, who's in the attack. So I'm printing that out there. I want to know how many times this loop's running in case I'm running it too many or too few times. And I want to know if this if statement is triggering at the right time. So when the if statement triggers, I want to know who it is and what their health was. So this is going to give me enough information, hopefully, to see what my problem is. So I compile this again, and I run it. Okay, main fight loop running current is 0. Prince Zuko attacks Aang. Aang has been knocked out. Aang attacks Prince Zuko for this. Current equals 0. Has been KO'd, health minus 15. So, I know that my KO check, it was that if statement, was working. And it was that person, and then the main loop runs again, and current is 0 again. So, I know that my if statement was working, and current companion was being increased here. But then the next time I go to attack, current companion is 0 again. And so I need to look at why current companion is 0 the next time the loop happens. And now you start to see, well, of course it's 0, Mark. You set it to 0 every loop. You created a new current companion variable each time, and you set it to 0 at the start of the loop, so it's always going to be the first companion. This is going to get ignored because I changed the current companion, and then this variable that I created inside a set of curly brackets evaporates and disappears when the curly brackets close here. So the next time I start the loop, the one that I changed is gone and a new one is created. And I don't want that to happen. So I want the current companion to be tracked outside the loop. If the current companion is tracked outside the loop, then any changes we make to it will be persistent through multiple loops. As opposed to if I made it inside the loop, it's a new one each time and it always starts at 0. Now this one will have different values. So let's try this again. Someone saying time to start the assignment. Yes. The best time to plant a tree is 50 years ago. The second best time to plant a tree is now. I love that proverb. So it's kind of like, yes, it would have been good to have been prepared and to be working earlier, but if you weren't, then go now. Now is good. Yeah. Okay, so if I do the current companion outside, I'm going to turn these off for now, just because I think it might work with that. And then we'll see whether this does work or not. Okay, so we're going to recompile. Let me just shrink that a little so it's not being hidden by the icons. Oops. 68. You are performing an operation but not saving the result. Did you mean to print or store the result as a variable? Bender fight 68, 70, something's going on there. Oh, when I said I was going to comment out this print statement, I only commented out the first line of it. Okay, I'm going to use my commenting style that can comment a large section out like that for that one. So now only things that I have in here are the functional bits of code. The bits of code that were giving me more information, this printf, and this printf are now not running because they're commented out. Okay, I'm going to save that, compile that again. Alright, that compiled. Now we're going to run the Bender fight and see whether that worked correctly this time. Ooh, this looks better. Zuko attacked Aang for 20 damage. Aang was knocked out. Aang was able to at least attack Zuko for 10 damage when that happens. Then Zuko attacks Katara, so this is good. We've got this combo happening here. So Katara attacks Zuko for 7 damage, which means Zuko, I think, has taken 17 damage here at the moment, so has 3 remaining, but Katara got knocked out, so Zuko attacks Sokka. Sokka gets knocked out anyway, even though he's the... Get it? Sokka for punishment. He got knocked out anyway. He still only did Zuko 2 damage. Zuko attacks Toph for 20 damage. Toph got knocked out, but Toph attacked Zuko for 6 damage, and Zuko was knocked out. We have a double KO. And I forgot to wear that t-shirt. I actually have a t-shirt, a Street Fighter t-shirt that says double KO. And I really should have been wearing that today. I forgot that this was the example I was going to do that actually had a double KO in it. So, this fight has happened. And through all of that, changing which struct we were looking at, changing the health on all the structs, looping through multiple times, checking that someone was alive to fight, we have ended up with a result where all the teams got knocked out and everyone's just lying on the floor, KO'd. So if we go back and have a look at that code there, the stuff that was happening, I'm going to get rid of these printfs now because they're now ugly and looking like comments, which they aren't. This main loop with this crucial still alive function and the ability to have the current companion that changed every time someone was knocked out, we now have this this nice cycle for this kind of simulation of a game that that can go through the different elements of the array. It can make changes to the elements of the array as well as making changes to the variable itself, because every time we did an attack we were passing in pointers to benders, which allowed us access to the memory that's in that bender and allowed us access to change it. And that's here in the attack function. And we're reporting some information and stuff like that. I think at some point it would be nice to actually say how much health was remaining on them, maybe after the attack. We could put an else in this if statement here. And there's other things that we could do as well. I might make these slides and this code available to you because I'm going to wrap it up here. Because the next thing that we could do, which I haven't done here, is we could actually introduce a random number generator. So actually let me quickly go into the slides and show you, even if I'm not going to code it. So here, and then the main loop, which is going to be reasonably similar. It's actually slightly different to what we did. I was checking for knocked out before the fight instead of after, but you can do that way or the way I just did it there. Oh, we had other things where they could declare which element they were using, and so they could yell something out before they attacked and stuff like that. But if we wanted more variation, we could use a random number generator. So C has access to a random number generator. It's not pure random, it's just the idea of random numbers. What this will do is gives us sequences of numbers that appear random to us as humans. So I'll give you these slides, and if you want to, you can work through and add a random number generator to this thing. So there's stuff like setting up the random number generator, which is called seeding it. And then doing things where in our attack, instead of having attacker power, we could have a random number which is modded with the attacker power, so the attacker does 0 up to their power. And so they could do different amounts of damage based on their power using a random number generator. And then it's kind of fun to watch because you could run it over and over again and you could get different results each time. So either the team wins or Zuko wins and that kind of thing. So yeah, that's where we are with that. I will give you these slides and the code that we're up to there. I'll put it in the lectures section. But there's a battle with benders, but the important thing, more than the whole Avatar The Last Airbender thing, is we were able to declare a structure. We were able to use it like it was a variable. So we declared one element of it on its own, and we declared 4 elements of it inside an array, and we were able to use that. We've passed pointers to these structures to a function, and that function was able to act on those pointers. Sorry, not act on those pointers, act on those structs themselves. So it was able to go to those structs and change their health values. So that's the nice thing about pointers. We give pointers to a function, the functions get access to the variables themselves. So I think if you want challenges for this, you can go through these slides after I make them public and see if you can continue this implementation, because actually my code in here is slightly different from the stuff I wrote. You can continue this implementation and see if you can do things with both random, where are they? Yeah, both random numbers and maybe having things like saying more things, but who uses what element and what health they're on at that particular point in time. You could have other functions for status if you want to. I say if you want to because there is another thing that you could be doing right now, which is based on Minesweeper rather than Avatar The Last Airbender, and I have a feeling that people are going to want to work on that instead. But you can take a lot of this stuff that we did today and think about it, because the idea of working with structs and pointers and stuff is definitely what we're going to be doing in the second half of the course and in the second assignment. So you don't have to worry about it too much now for Minesweeper. Minesweeper has simpler C constructs in use, but we're definitely going to be using it later. I will hold for a second and see if there are any questions anyone has about this now, and if not, I will then end the stream because I've gone overtime. Ironically, I've gone overtime by nearly exactly the amount of time we spent talking about taking the course to pass fail and stuff like that. Which I'm still sorry that we're doing that, um, but it kind of has to be done. But that doesn't make it, like even if you're forced into something, doesn't mean that we can't have some compassion for the fact that you're being forced into something that you didn't want to do. And you're being forced into something you didn't initially sign up for as well, because it's not how we said the course was going to run at the beginning. So it's totally okay if you're not okay with this. And if you're not okay with this, and you want to talk to me about it or anything, you can email the CS1511 email address. I put that out in the notice as well. I'm going to read all of those, and I'm going to try to reply to all of those to talk to everyone who has issues with this, because it's a tough situation, and even though I can't change the situation that we're in, I can at least try to make us feel okay with what we're doing. That's the best we can hope for, I guess. And if we do feel okay about what we're doing, then hopefully that means we can still put the effort in that we wanted to put into this course, and we can still get all the learning that we're trying to get out of this course. Because I think there are a lot of people who are like, really pushing for a certain level of marks in the course, which means you wanted to put your time and effort into things like the assignments and studying for the exam and stuff like that. And I really don't want you to not put that effort in. I want you to still be able to put that effort in, and feel like you're getting something out of it, which is why we're still marking the course entirely numerically. And it's only at the point that we submit it to the Faculty of Engineering that we are going to convert it into a pass-fail. So every step along the way, we're going to give you your full marks, so that at least you and I know that what you've done in this course, and you will always remember what you did in this course, how well you did in this course, and the feedback you got from this. And so, you know what? The whole idea of the university, the institution, whatever, you knew how well you did in the course, and I think that's more important than whether the uni knows. Yeah, okay, so let's see if there were any questions there. Oh yeah, Tom was putting in the email address. Simply Me asks, why is include standardlib.h in the starting code for the assignment? So the standard library has some capabilities for the assignment. I can't remember what we were actually using for that. Hang on, let's have a quick check. Did I have Minesweeper? So if I remember correctly, this is just the starter code. Did we use anything? Tom, do you remember if we used anything particular in here? I don't think we even did. No, I'm not seeing any standard lib things. I think this is because when we built the reference implementation that we were using to show you things, we had standard lib in there because we were doing some special stuff with some libraries in the back end that you don't need to worry about. So it does happen to be here in your assignment code, but you don't have to worry about whether it's there or not. I don't think there's anything in here that you're actually specifically using. Yeah. There is an option for EOF. EOF is actually there in standard input-output because EOF is part of input and output. So I think EOF is defined in both of these, but you won't need standard lib to get EOF. Sam may have used it for something. if you've reached a certain point in the assignment, there could be things that might be useful from standard lib. If you are doing any of the Hall of Fame challenges, there's definitely some of those that need standard lib. They don't work without it. For example, oh no, wait up. Is the random number generator standard lib, or is it in its own? I can't remember if it's in its own. It'll be right here. It is C standard library. So it could be that we did random placement of mines in our testing in the reference implementation, and then we left it in there when we pulled all of our implementation out. Yeah, and also for people who are writing C a lot, it's a habit to kind of put. You know how I've been putting standard I/O in every file that we've written. A lot of people put standard lib in every file they write as well, because once we hit a certain point and we're using a certain set of tools, we will nearly always use standard lib in every single program that we run. Okay, I'll just leave it open for a couple more seconds for another question, but I really should head off because I don't usually teach for 2 hours and 40 minutes straight, because I didn't take a break either. I just ran all the way through and wrote code. So let's see if there are any more questions there. I'll let the stream catch up with the buffering and see if there's any questions, and if there aren't, I will wrap it up. Okay, looks like that's where we are. Thanks everyone for coming along. Thank you for sticking around for the extra long stream. And again, if there's any issues with the pass-fail nature of the course that we're going into, you can talk to me about it. I'll try to answer as many people as I can. We will tell you more about the exam as we actually figure out how it's going to work, because I've been trying to sort of figure out exactly what the exam is for the last couple of days. Well, not even the last couple of days. I think it's only been about 24 hours, or a little bit more than that, since we knew that things were going to have to change. So we'll have solid information on that soon, and we'll make changes to the course outline so that the course outline actually has the correct information for this course. But wherever we make changes in that, will be really, really clear what's changed and how. Thank you all. And I'm glad people are thanking Tom as well. That's really nice. And I will see you all next week. Well, I'll see you all virtually next week, at least.